So page 771, 12.24, we want to be rich. I don't want to be rich. I just want to have everything that I want, right? That's all. A couple Ferraris, Lamborghini, maybe you know, a place out in some island somewhere where the water's clear and blue, right? And you can like catch fish with your snorkel and a spear or something. That'd be all right. I'd be okay with that. That's not rich. All right. So what this problem is saying is, it says in a recent year, 73% of first-year college students responding to a national survey identified being very well off financially as an important personal goal. A state university finds that 132 of an SRS of 200 of its first-year students say that this goal is important. So they're saying 73%, or 0.73 of first-year college students are saying that this being very well off is important. Is that a p-hat value or a p-naught value? Is that a claim or is that the sample proportion? P-naught, it's the claim. They're saying that 73% of all first-year college kids are saying this. So this is going to be the p-naught, or the population proportion. Then it goes on to say that 132 of an SRS of 200, so I've got 132 of 200. What's the 200? That's n, right? That's your sample size in this case. So if n is 200, what's the 130? Or is it 132? It is 132. I wrote it wrong. What's the 132? Now, sample size is the 200. This is your success. This is how many out of the 200 said that they wanted to be rich. Anybody know what value we set that? What variable? X. Yeah, it's X. We use X for that. X is your success number. How many were success? How many did we see as a success over how many did we question? So in this case, my p-hat then is going to be X over n, which is 132 over 200. And that is 66%, is it not? 0.66? Yeah. Okay. Now, it wants us to say if there is good evidence that the proportion of first-year students at this university who think being very well off differs from the national value, 73%. So they're kind of giving you that. So we need to state our null and alternative hypothesis. The null is that the population of first-year students who think that being rich is important equals our p-naught value, 0.73. The alternative, it said differs. Is that greater than, less than, or not equal to? Not equal to. Good. It's a two-tailed test. So they don't know if it's greater than or less than. They just want to know if it's different. So we need to check our conditions. SRS, that was given. Independent, I'm going to say that if these students are questioned into, apart from others, that this would be a reasonable thing to think of as independent. If you're questioned in a group and somebody says, yeah, I want to be rich, that might influence everybody else, right? So depending on the questioning, I'm going to assume students are independent, or student responses are independent. I think that's a reasonable assumption. Normal. We have a little bit of work to do here. We really need to look at rule of thumb 1 and 2. Is our population greater than or equal to 10 times our sample size? Do you think that there are more than 2,000 first-year college students in our nation? Yes, probably in some colleges, not just in our nation, right? So rule of thumb 1 is met. That means that we can take find the standard deviation. Rule of thumb 2 is going to be n times p, so 200 times p, or p naught in this case. Is that going to be greater than or equal to 10? Yeah, if it's pretty obvious, you don't need to calculate it out. That's pretty clearly greater than 10. And how about 200 times 1 minus 0.73? Is that also greater than or equal to 10? Yeah, most definitely. If you're not sure, check it. But I think that's very clearly going to give us a percent that's greater, or a number that's greater than 10. So our conditions are met. We can go ahead and move on with our calculation. So our calculation is going to be p hat minus p sub naught over the standard deviation of p naught, 1 minus p naught all over n. If you want to just put p's in there and you can keep that straight, that's perfectly acceptable to me. So we have 0.66 minus 0.73 divided by square root of 0.73 times 1 minus 0.73 over 200. Now we need to be careful when we put this in. I like to put this in and then hit equals first myself. So I get negative 0.07. I'm going to divide that by, I don't really need parentheses here. I can go into the square root and be very careful. As long as everything's underneath the radical, the order of operations is going to come into play here. I don't need any extra parentheses. It's going to work out just fine, and I get negative 2.23. So that's our test statistic, or our z-score. So I've got to go to table A, which I have somewhere here. And I'm going to look up negative 2.23. So negative 2.23 is 0.0129. So this is our p-value. You know what we forgot? Is we forgot to set an alpha. I don't think this problem sets alpha for us, does it? I don't believe so. So what's a reasonable alpha for this, do you think? I know you guys are going to be like, first year college students next year, so it might become life and death for you, right? But probably not. 5%, 10%? Does anybody have a preference? You think 10? It's not that important? Okay. Yeah, I kind of agree. I think if alpha is 10%, we're... Now, keep in mind, this is a two-tailed test, so what does that do to alpha? It's going to split it, right. So we've got 5% at each end. We're on the smaller side of things, and our p-value is definitely less than 5%. Our p-value is way here, a little bit more than 1%. So we are significant, So we're going to say that we have significant evidence to reject the null. And conclude the proportion is different than the proportion of students who want to be rich is different than 73%. Okay. I think that would work just fine. Now this question goes on to ask us to put this into a confidence interval as well at 95%. So what it's looking for us to do is to make a judgment based on this sample about where we think the true proportion is. Because we've just said that we don't think it's 73%, right? We've got significant evidence that says that it's not that. So where is it? So I'm not going to do that calculation with you, but I will give you the formula. Your conditions are already met, okay, so you're good there. Even if you change the conditions to 0.66 here for you're going to be just fine. The formula you want is p hat plus or minus z star for 95%, that's up here on the board, is 1.96, times the square root of p hat times 1 minus p hat all over n. So the calculation is all in here. You've got p hat, you've got n, you've got z star. Why do we use p hat here instead of p naught or p? Why would that be the case? Because clearly this is going to be different than what you got here for this portion, right? We're using a different value. It's going to be different. It's not going to be a lot different, but it'll be different. The reason this has p hat in it and not p or p naught, even though we have that from the previous problem, is because it's asking you to make a judgment call of what p really is. How can you use something that is a claim? You're only using a sample in this case. You use only what you have. And what we have, what we know, is that 132 out of 200 have said that they want to be rich, right? So you're making an interval about p. So you can't use p in something that you're trying to make a claim or a judgment about. All right, so I'm stumbling on my words enough. It's time for me to hush up and let you guys work.